Hello and welcome again. Now in this section we are going to discuss about the Google Cloud Services overview. This is the first chapter and later on we will discuss each and every module of the Google Cloud. Each module have different sections, like compute have different domains, networking domains, DevOps, development, AI, machine learning and so on. So let's get started. So what we will discuss in this section that why Google Cloud, run on Google Cloud infrastructure, what services will run on Google infrastructure, and the focus on your product. Mix and match services is one of the key point, because if we talk about the architecture, it means that we have to use different services, scale to million of users. Google Cloud is underpinned by the same infrastructure and innovation that powers Google product. Google ability to build, organize and operate a huge network of services and fiber optic cables with an efficiency and speed that rock physics on its heel, right? So why Google Cloud? It's very simple. Google have its own fiber optic, Google have its own efficiencies, Google have multi-region deployments which you will not get any other cloud providers. So Google Cloud is actually have a good and same infrastructure with some innovation that help to work on the Google Cloud products using some differentiations which we will check later on this course. So why Google Cloud? What things which make Google Cloud different with others? So let's check. It's a physical network, thousands of fiber miles and those many thousands of servers that aggregate add up to the mother of all cloud. Built on the same infrastructures that allow Google to run billions of search results in milliseconds. That's the beauty of the Google Cloud infrastructure. It serves 6 billion hours of YouTube videos per month and provides storage of more than 1 billion Gmail users. It's on global networks, redundancy and innovative infrastructure. Number 2, focus on your products. So if we see the Google Cloud products is rapidly developed and mostly available very near to Google customers, right? So Google manage your application, database and storage servers, so you don't have to worry about it and you can easily focus on your specific product, like your app and your services which you want to deliver to your customers with the help of Google Cloud. Google have the managed services, developers tools and SDK and console and administration. By the way, we have already used the console to make the Google Cloud billing and the project. Now let's talk about the mix and match services. So let's say you have a virtual machines, you have the Google Cloud storage called the blob storage, you have the block storage called the elastic block storage, you have the NoSQL data store, you have the MySQL database, you have the big data analytics using the BigQuery. So these are the mix and match services which actually help you in order to make a good multi-tier architecture and multi-tier infrastructure. So Google Cloud Platform has all the services your application architect actually needs. So in the mix and match services, we have compute, we have storage, and we have different services other than the infrastructure. Now scales to millions of users. What does it mean? It means that using Google Cloud services, you can scale your services using horizontal scaling or vertical scaling. If we talk about the horizontal scaling, it means you can set up the auto scaling setup. If we talk about the vertical scaling, it means that you can increase the RAM and CPU on your existing machine by shut down the machine and just change the machine type. So in terms of scaling, we have 4 options: scale up, scale down, scale out and scale in. If we talk about the scale up, it means we are talking about the vertical scaling, right? Vertical scaling means if you have a 2 GB of RAM in the specific compute, you just shut down the machine, increase the RAM to 4 GB and just power on. Scale down means vertically decrease. 4 GB of RAM, you can decrease the RAM to 2 GB in order to save your cost. Similarly, scale out and scale in for use for the horizontal scaling. Scale out means going from left hand side to the right hand side, increase the number of compute machines on the similar basis. Like you have a 2 GB of RAM, without shutting down in the specific event, you can create a multiple virtual machine on the same site, and if the traffic goes down, the scale-in process start and terminate all the new created machine once the traffic goes up on that specific time. This scale out and scale in used for some specific eventually process. Now let's talk about the summary. What we have already discussed. So Google Cloud leverage robust infrastructure, innovation, and the reliable and scalable platform. It allowed developers to focus on their products by handling system administrators, a wide range of services using Google Cloud, using innovations, mix and match services, and the scaling services. Now, Google Cloud offers flexibility with a variety of services and automatic scaling, ensuring cost efficiency and adaptability for applications. This is the very important factor, because Google Cloud help us to create a new services using Google Cloud resources and infrastructure. So what we will discuss in the next lecture, we will discuss about Google Cloud product domains, GCP compute services, and these compute services based on different separate services which we will discuss later on. I hope you enjoy my session. Thank you. See you in the next lecture. Hello and welcome again. Now we have already discussed the cloud services overview, and we have started our journey towards to understand the cloud services. So Google Cloud services evolve over time. It means that there is some enhancement in the services time by time. So what you need to do, it's a tip that you need to ensure that your knowledge is up to the mark and up to the date, and you need to learn the official Google Cloud documents after every 2 to 3 days or weekly basis, right? Remember, Google Cloud certification includes recent updates. So if you are outdated or if you didn't read the official documents, it seems to be hard to pass the Google Cloud Associate or professional exam. I hope you understand the tips. See you in the next lecture. Thank you. Hello and welcome again. Now we are going to discuss about the Google Cloud Compute Services domain, and in this section we will discuss about the multiple Google Cloud Compute Services. So let's get started. Before moving forward, let's break down our sessions. Number one, Google Cloud product domains, Google Cloud Compute Services. Remember, Google Cloud Platform is actually the set of services which is divided in multiple domains, and each domain actually focus on each set of services. Let's say if we talk about compute domain, in the compute domain we have the list of services related to compute. This actually enable developers to build, test and deploy application using Google Cloud mix and match services. So actually following are the Google Cloud Services domain, which include AI and machine learning, API management, and compute, containers, data analytics, databases, healthcare and life sciences, hybrid and multi-cloud, IoT or called Internet of Things, media and gaming, migration, networking, operation, security and identity, serverless computing, storage, containers, developer tools. So these actually are the domains, and each domain have multiple services. Now let's talk about compute services. So in the compute services we have compute engine, app engine, container engine, container registry, and cloud function. In the compute engine, we normally discuss about the virtual machines. So if we talk about virtual machines in AWS, we called EC2, Elastic Compute Cloud. In Google Cloud, we called it GCE, Google Compute Engine. is actually the infrastructure as a service called IaaS components of a Google Cloud platform. So it's built on Google infrastructure that actually run search engines, Gmail, YouTube, and other services. Google Compute Engine actually enable users to launch virtual machines on demand. Now let's talk about Google App Engine. Google App Engine is actually enable you to build and host application on a same system that power Google applications. Now App Engine is actually offers fast development and deployment and is a Docker based, containerized based service with no need to worry about hardware, patches or backup because the backend is actually managed by Google Cloud. Many enterprises is actually migrating to the cloud to reduce management overhead and increase the agility and speed which they can run your business using physical hardware. So using bare metal solution, you can bring your specialized workload to Google Cloud, allowing you to access integration with GCP service and minimal latency. Cloud GPU or the graphic processing unit is one of the innovative service inside the Google Compute Engine. Is actually help graphic designers and for those who actually run the rendering services on Google Cloud Compute service, right? So using GPU, you can run GPU workload on Google Cloud with industry leading storage, networking and data analytics technologies. It's called a mix and match service on Google Cloud platform. High performance GPU on Google Cloud for machine learning, scientific computing and 3D virtualization is actually the good thing on Google Cloud, and graphic processing unit is the cutting edge technology, you can say, which increase the demand of the Google Compute Engine. Let's talk about Cloud Run. Cloud Run is actually the serverless Docker service. Serverless Docker service, what does it mean? It means that you don't need to worry about the backend hardware or the front end hardware. You just need to set up the services and then it will be run on Dockerized environment, which is actually the serverless Docker. So develop and deploy highly scalable containerized application on a fully managed serverless platform. Is not a Google function, remember. It's a Cloud Run, which is similar to Google function but is for the managed services on serverless platform. So you just write the code using your favorite language. It's suppose Go, Python, Java, Ruby, Node.js and more, right? You just write the code and then deploy the services. Rest the thing it will manage by itself. So what's the beauty of Cloud Run? So the beauty of Cloud Run is the abstract away all infrastructure management for a simple developer experience. If you are a good developer or if you are a DevOps engineer, you just need to write the code, or if you have an existing code, just put it as a service and upload on a Google Run infrastructure and rest managed by itself. Google Run actually will give you the link and you just open the link and your service will open and running, right? So build upon an open standard Knative architecture, enabling the portability of your application and enhancement as per your requirement. Now the another service is Migrate for Compute Engine. This service is for those who want to migrate their infrastructure from on-prem or from other cloud to Google Cloud. But this create a lot of questions. So Migrate for Compute Engine by Google Cloud has the answer, right? So using Migrate for Compute Engine service along with the StrataZone, which is actually the Google based transfer service, which actually help you to recommend and calculate the existing infrastructure workload and the recommendation based on the StrataZone report, so that you can easily migrate your existing infrastructure on the Google Compute Engine using the Migrate for Compute Engine service. This actually help you to check which services have low priority, medium priority or high priority. It means that you can easily connect or migrate your existing infrastructure as per your requirement of your workload. Migrate for Compute Engine gives IT team the power to migrate the system to Google Cloud without any hassle. Now let's talk about the preemptible VMs. So preemptible VMs are highly affordable, short-lived compute instance suitable for batch jobs and fault-tolerant workloads. Preemptible VMs actually offer the same machine types and an option as regular compute instance, but it's just like the spot instance on AWS. So this actually help to check the services on very low cost architecture. So preemptible VMs is actually help you to run the compute up to last 24 hours, but the price is up to 90% reduced. Now let's talk about the recommender. Recommender is the service which actually help Google Cloud admin just like you to check and making decision proactively before anything's happen. And this actually help the machine learning approach. Let's say this will help you to check your day-to-day cost and day-to-day security checks before anything happen and before your cost go sky high. This empower team to automatically detect issues like overly permissive access to a wrong size VM. Let's say you need 4 GB of RAM, but you mistakenly create a 8 GB of RAM and you are not using them the whole amount of RAM which you actually put it in your specific machine. The recommender recommend you to reduce the size of machine of 4 GB or 2 GB in order to reduce the cost up to 70%. Now let's talk about the shielded VM. So shielded VM are actually the virtual machines on Google Cloud hardened by a set of security controls that help defend against rootkits and bootkits. So shielded VMs are actually protected by the DDoS, and thanks to Google Cloud provide these services. So these services is actually help and prevent our infrastructure from outside attacks, especially DDoS. Let's talk about sole tenants. Sole tenants is actually the physical compute engine servers dedicated solely to your workloads. So sole tenants nodes offer the same machine types and options as regular compute instance, including custom machine shapes, transparent maintenance, but on servers dedicatedly exclusive to use. So sole tenants are for those who are actually looking the physical hardware on Google Cloud platform. SQL servers on Google Cloud. This is one of my favorite servers, right? So you can migrate or run Microsoft SQL or Cloud SQL. It means the PostgreSQL or the MySQL, right? So you can use 3 different SQL servers, but yes, you cannot use Oracle servers because Oracle have different clouds, or Oracle is the only database which is not available on platform as a service on SQL server service on Google Cloud. So what you can do, you can create a fully managed Cloud SQL server, or it's a fully managed means that Google Cloud will manage itself, and you just need to put it some parameters and rest of the things will manage by Google Cloud itself. So use a fully managed Google Cloud SQL for SQL Server to reduce optimal and operational overheads. It's a fully compatible and configurable custom VM shape, help to optimize cost. Google Cloud VMware engines. So for VMware lovers, if you are working on ESXi server, if you are working on vCenter servers, this Google Cloud VMware engine is good for you. So Google actually partnership with the VMware in order to make a hybrid cloud with VMware and Google, so that you can run your workload either on ESXi or either on Google Cloud platform using the VMware engine. Using the VMware engine, you can actually redundant and dedicated 100 gigabit networking infrastructure, and you can easily manage your existing VMware or on Google Cloud infrastructure which is migrated from VMware. It's actually providing 99.99 availability to meet the need of your most demanding enterprise network. You can easily migrate your VMware environment with just a few clicks. So thanks to Google Cloud to provide the VMware engine service, which actually help and connect and sync with the existing VMware environment and easily migrate the workload from VMware to Google Cloud or create a hybrid environment. You can run a fully managed native VMware Cloud Foundation software stack or unlock intelligent insight from your existing data with native service. So the summary is Google Cloud Compute is actually the IaaS called the infrastructure as a service, offering enable the on-demand launch of virtual machines on a global infrastructure. App Engine simplifies application development and hosting, provide fast development, scalability and hassle-free administration. Bare metal solution is actually help you to create a physical or graphical processing units called the GPU based infrastructure with you, so that you can easily run your infrastructure on a sold NAND node, bare metal node or a graphic processing unit node. Cloud Run is actually provide the serverless .NET architecture and provide the flexibility, deploy the solution, and definitely we will use these services later on this course and we will focus individually on these services one by one. So migrate for compute engine is actually the streamline the migration of the application from various environment to Google Cloud. So Google Cloud actually offers the security enhancement like shielded VMs, resource isolations. You can use the sole tenant nodes just like I discussed, just like the bare metals. You can use the sole tenant nodes along with the support of the SQL Server workload, which you can run on the Google Cloud SQL service and the VMware engine Google Cloud environment. So like I said, these are the mix and match services which you can combine together to make a complete architect. Let's talk about the data analytics service. Is actually the Google BigQuery service, Looker, Dataproc, the PubSub services and Data Studio, and last but not the least the Google Cloud Data Flow. I hope you enjoy my session. See you in the next lecture. Thank you. Hello and welcome again. So before moving forward, let's talk some tips and tricks about the Google Compute services. Tip number one, when dividing the Google Cloud services, you should start with the fundamental services so that your fundamental should be strong in order to understand the other services. Number two, like Google Compute Engine, Cloud Storage and Virtual Private Cloud, these are the core services like compute service, storage service, network service and database service. These services are the key points and pillars in order to make a good architecture from scratch. Thank you for watching. See you in the next lecture. Hello and welcome again. So now in the last videos we have discussed about the Google Cloud Compute services. In this video I'm going to discuss about the Google Cloud Analytical services, which will help you in order to work on the Google Cloud Analytical Services group. So let's get started. If we break down our lessons, so we have Google BigQuery service, Local service, Google Dataproc service, Google Cloud PubSub service, Data Studio service and Cloud Data Flow service. So what is BigQuery service? So BigQuery service is actually the highly scalable data storage service which actually accommodate up to 100 of terabytes of data you can easily look up and query as per your requirement. You can create multiple data sets and you can get and gather the data using the multiple data sets. This actually help you to perform the ad hoc queries or multi-terabyte dataset as well, and you can share data insight via web or using the histogram or pie chart as well. So using the local service you can gather the data and then show using the histogram and pie chart, and using the business intelligence and analytical model to integrate and link with the custom data apps. So Looker often a unified surface to access the troubleshoot most up-to-date version of your company's data and show on the analytical versions, so you can show with your clients, with your customers about your data. Let's talk about the Google Dataproc. So Dataproc is actually the fast, easy to use, manage Spark and Hadoop service for distributed data processing. it provides management, integrations, and development tools for unlocking the power of the rich open source data processing tools. And you can use Dataproc with BigQuery and local. It is designed to provide reliable many-to-many asynchronous messaging and use the pub/sub message for publishing and subscribe your notification and alerts, and using to looping the data so that you can create a query based setup for your applications and to make a waiting query so that once the data is processed, the pub/sub service will hold the data until your data is processed. By decoupling senders and receivers, Google Cloud pub/sub allow developers to communicate between independently written applications, and using the query methods you can create a different polls. So using pub/sub services you can hold your process data until the processing is complete, so that you will not make a long queues directly on the application, so that the application will not get slow. You can create a queues on pub/sub, and then once the application is free, it will automatically get the data from the pub/sub queues. Now let's talk about a data studio. Data studio is very intelligent tool that is actually linked with the BigQuery service, and it's allow you to turn your data into an informative version, right? So you can the detail pie charts and detail histogram using the BigQuery data on Google Cloud Data Studio. If you want to create a data pipelines, you can create a cloud data flow, which is actually the fully managed service for strongly consistent parallel data processing pipelines. So if you are looking at parallel data processing pipelines, Google Cloud Data Flow is one of the good option. So Google Cloud Data Flow, actually this service manages the life cycle of the Google Cloud Compute Engine resources for the processing pipeline. So if you're creating a CI/CD pipelines, so the data flow is one of the good option to migrate the data from one option to another options, right? It also provides the monitor user interface to understanding the pipeline health. So this is very good option for data flow on the object based data. So if we summarize what we discussed, the analytical tools, so Google Cloud offer the suite of analytical service which include the BigQuery, Looker and the Dataproc. And if we want to enable the organization to analyze massive data sets, generate insight and share them via user friendly dashboard. Google Cloud Data Flow actually simplifies the development and management of parallel data processing pipelines, while pub/sub facilitate asynchronous messaging between applications, enhancing data processing efficiencies. Google Cloud Data Studio actually empowers the user to create informative, customizing an innovative dashboard using the existing data based on the big queries. So you can show the data with your customers using the dashboard reports and make it easy to visualize, and the future perception and future decision will be very easy using the Google Cloud Data Studio, because it get the data from BigQuery, show the data on Google Cloud Data Studio, and the customer will get happy. So what is next topic? So next topic is actually the Google Cloud Database Services, which includes the Cloud Bigtable, Cloud Spanner, Cloud SQL, Firestore, Memory Store, and much more. So see you in the next lecture. Thank you. Hello and welcome again. Now in this section we will discuss about Google Cloud Platform Database Services. So let's get started. In the GCP Cloud Database Services we have Cloud Bigtable, Cloud Spanner, Cloud SQL, which is actually the combination of different database engines, file stores, memory store, and much more. Let's start with the Cloud Bigtable. So Cloud Bigtable is actually NoSQL database service. When we talk about NoSQL, it means there is no architecture available, there is no raws available, right? So this is NoSQL, SQL query structure, right? So Cloud Bigtable is actually the fully managed, highly scalable NoSQL database service, and it is designed for the collection and retention of data from 1 terabytes to 100 of petabytes. It include hexabyte and petabyte as well. If we talk about Google Cloud Spanner, so in the Google Cloud Spanner is a fully managed mission critical relational database service, and it is designed to provide a scalable online transactional processing database. So it is designed to provide a scalable online transactional protocol that's called the OLTP protocol. Now if we want to create and set up the Cloud SQL including PostgreSQL, MySQL and MS SQL like Microsoft SQL, we need to use Google Cloud SQL service. It's a fully managed database service. Maintain, manage and administrators your database, allowing you to focus on your applications and services easily, so that we don't need to install the Cloud SQL service on our Google compute machines. So NoSQL document database for storing, syncing and querying data for mobile and web applications. So Cloud File Store is one of the database service for big data, and it helps for client applications for backend like client libraries, which provide the live synchronization and offline support. Google Cloud Memory Store is actually the managed in-memory service, which is based on Memcache and Redis cache, and it helps to reduce the long queues and the slowness of the databases. So let's discuss the summary, what we discuss about the NoSQL and the Bigtable. So Google Cloud offer a range of databases, which includes the Bigtable called the NoSQL, Spanner, which is a multi-region Cloud SQL service, a SQL service, Firestore, and the memory store, which includes the Memcache and a Redis cache. So to meet the various data storage, we need to set up the NoSQL to relational database and in-memory data stores as per our requirement. So these services are fully managed and allowing users to offload database administration tasks, and is provide the scalability and ensure that databases can grow as needed to handle data demands. Now the next lecture is the Google Cloud Storage Services, which is actually the object storage services, which includes the archive storage, cloud data transfer, Google storage, cloud file store, local SSD and persistent disk. I hope you enjoy my session. See you in the next lecture. Thank you. Now let's talk about the Google Cloud Platform Storage Services. In this section, we will discuss about the archive storage, the Google Cloud Data Transfer, Google Cloud Storage, Cloud File Store, local SSD and a persistent disk. So let's get started. Now let's talk about the archive storage. So archive storage is the part of Google Cloud Storage which actually help to save your cost and to retain your storage file for a longer time, which includes the nearline, cold line and archive offer, which includes the ultra low cost and highly durable, highly available archival storage. Remember, if you buy or use the cold line, this will save your cost and you can store your data for a longer time. For access data less than once a year, archive is a cost-effective storage option for long-term preventions, like I said, like a cold line and nearline. Cold line is also ideal for cold storage, like you want to store your data for 7 years, 10 years or 15 years. Whether you have 50 gigabytes or 50 petabytes of data, whether you have access to a T1 lines or a 10 gigabit network connections, the Google Cloud Data Transfer help you to transfer your data from one area to another area, and Google offers solution to meet your unique data transfer, which you can check like on-premises data to cloud data using T1 lines or the 10 gigabit circuits. Remember, 10 gigabit network connection is only available for interconnect. The VPN connection will not allow you to use the 10 gigabit network circuit. Google Cloud Storage RESTful service is for storing and accessing your data using a Google Cloud infrastructure. So the RESTful APIs is help for those who want to use the programmatic access and to link the Google Cloud Storage service with your application. So Google File Store is actually the scalable and highly available shared file service which is fully managed by Google. Cloud File Store is actually provide the persistent storage for shared workload. Like if you have a shared workload for multiple machines, so Google File Store is one of the good options because you can easily share your file among multiple computers or servers. So Google Cloud File Store is best suited for enterprise application, which is the POSIX complement file system, NFS network file storage, and the for file sharing for Windows and Linux machines. Local SSDs are physically attached to the server that hosts your VM instance. This tight coupling offers superior performance because local SSD is actually built within the server, not for the shared storage. So it will increase the latency and the performance and reduce the time to read and write. But there is a drawback: if you stop the machine, all data will be wiped out on the local storage, because in the second time the machine will be run on another server within the cluster. Let's talk about the persistent disk. So persistent disk is actually the reliable high performance block storage for virtual machine instances, and it industry leading price and performance, including SSD called the NHDD. So if you talk about the SSD is the solid state drive, and HDD is the simple hard drive called the magnetic hard drive. So SSD price is higher, but the performance is also higher. So I would recommend to use the SSD for all the operating systems and all the workloads. But if you just want to save your data and just share your data with others, so keep the HDD with your server. So let's talk about the persistent disk. So persistent disk is actually attached the virtual machine instance running on a Google Compute instance. This actually the hard drive which helped you to run the operating system, the drives, the data, and other items. And not only in compute engine but also the Google Kubernetes engine as well. Temporary transparently resize, quickly backup, and support simultaneously readers. What does it mean? It means that you can connect multiple machines to read the data from the drive at one time. Now let's talk about the summary. So Google Cloud offer a range of ultra low cost archival storage option, which includes the nearline, cold line archive for a long term data prevention and saving for a long years. You can transfer your data easily using the Google Cloud Transfer Service, regardless of the location, data size, network speed, and seamless data migration. Google Cloud Storage Service encompasses scalable file, high performance block storage, and fully managed shared file system, which includes the diversified storage need with advanced security and reliability. Now let's talk about the next topics. So Google Cloud Storage Service includes the App Engine, Google Cloud Functions, Cloud Runs, workflows, and many other things. So see you in the next lecture. Hello and welcome again. So now in this video I'm going to discuss about Google Cloud Platform serverless storage services. So let's get started. So in serverless we have multiple options like App Engine and Cloud Function. We have Cloud Run and workflows. So let's start with the App Engine. So App Engine is actually one of the serverless service which allow us to use the Docker based applications on App Engine, and we just need to set up the YAML files and the complete application, and then you can use it using G Cloud. Remember, there is no GUI option for App Engine deployment. You can just check the results and just find the events. But if you want to deploy something on App Engine, you need to configure the gsutil and gcloud on your laptop or desktop, and then run the command gcloud app deploy and gcloud app destroy, something like that, right? And then you need to set up the local folder so that once you deploy the application on App Engine, the gcloud could get the application data from your local desktop or laptop to App Engine deployment or environment. Cloud function. So cloud function is just like the AWS Lambda function, and you can scalable pay-as-you-go model and pay-as-you-go function as a service like the FaaS to your code without having any server deployment. It's a zero server management. So no server to provision, no need to manage, no destroy, and no downtime, right? So it's a pay-as-you-go model, and it's a trigger base or the subscription base, you can say, the working on the cloud function. Mostly it work on the trigger base. Whenever you trigger something on the cloud function, it will charge. It's automatically scale on the basis of load and is integrated monitoring and logging and have the debugging capability. Now let's talk about the Cloud Run. Cloud Run is actually the develop and deploy highly scalable containerized applications on a fully managed serverless platform. Unlike App Engine, where you need to set up the configuration files and then deploy, in the Google Cloud Run you just need to provide the service file, service manifest file, and the rest of the thing is managed by Google Cloud Run itself. So you just write your code with your way using Go, Python, Java, Ruby, Node.js, and more. Abstract away all the infrastructure management for a simple developer experience and is built upon an open standard Knative. Remember, Knative is the Kubernetes native tool which help you to deploy the Dockerized application on serverless Docker or the generalized Docker environments. If we talk about the workflow is another service which actually orchestrates and automate Google Cloud API based service, which actually use the HTTP protocol. Is just like the AWS API service. If you are AWS user, so you can just compare this service with the AWS API service. And then it's a serverless workflow, so you don't need to worry about that, the server downtime and server configuration and management. Is automate complex process, so you don't need to be worried about the complex process issues. It's a fully managed service, required no infrastructure or capacity planning. Now the Google Cloud offer a range of serverless and managed services, which including App Engine, Cloud Function, Cloud Run, and Workflow. To be very honest, App Engine and Cloud Run is one of my favorite service because App Engine help me to scale my application without any downtime, and the Cloud Run is for where I just need to trigger base serverless architecture and the serverless Dockerized applications. The Google Run is my first choice. These services abstract away infrastructure management and allowing developers to focus on writing code and automating process without the need of server provisioning or capacity planning. So Google Cloud actually offering cater to various application types like promoting scaling, portability, and ease of use of developers and organizations. Now let's talk about the next topic overviews is the Google Container Service, which includes the artifact registry and cloud build, cloud run, container registry, and deep learning containers. Google Kubernetes Engine or the GKE, Kubernetes application on Google Cloud Marketplace, so we can buy the applications subscriptions using the Cloud Marketplace. I hope you enjoy my session. See you in the next lecture. Thank you. Let's talk about some tips and tricks. So the tip number 1, you need to be the mental mapping of frameworks, how different service interact, how and where you should use the App Engine, Cloud Run, Kubernetes Engine, Cloud Function, right? So the Cloud Run is just for the service base where you just need to trigger based Dockerize application. Cloud Run is the best example. If you want to deploy the small scale and medium size Dockerize application, App Engine is one of the best solution. And if you want to set up the highly available cluster based environment to deploy multiple Dockerize applications, the GKE, Google Kubernetes Engine, is the best environment. So understand the purpose of the service. Like I said, you need to know about the concept of VPC, Google Compute Engine, App Engine, Cloud Run, Cloud Functions, Kubernetes Engine. These are the separate services, including storage service as well. So you need to be very familiar before sitting on the exam that why this service is good on the specific scenario. Like BigQuery. BigQuery is for data analytics. Cloud Function is for serverless computing. Like I said, if you want to trigger something on the after some time or day-to-day basis, the Cloud Function is the best example. Cloud pubs up for event-based driven architecture, and this will help you to fit into the real-world infrastructure. I hope you enjoy my session. See you in the next lecture. Thank you. Hello and welcome again. So in this video we are going to discuss about Google Container Service. So let's get started. So in Google Container Service we have artifact registry, we have cloud build, again we have Cloud Run, because Cloud Run is the part of application service and a container service. We have container registry and the deep learning container, which is actually in the beta state. Google Kubernetes Engine and Kubernetes application on Google Cloud Marketplace. So let's discuss about artifact registry. It's actually on beta stage, or beta means that this service is not in production yet. So as the evolution of the container registry, artifact registry is a single place of your organization. It means you can manage container images and other languages like Maven, NPM, and any other language. You can just manage the images of these applications on the artifact registry. If we talk about the cloud build is actually the process for CI/CD, continuous integration and continuous delivery pipelines, where you can just build, test and deploy your applications on your serverless CI/CD platform. You can build software quickly across all programming language including Java, Go, Node.js and more. So using the cloud build, you can get complete control over the defining custom workflows for building, testing and deploying, and you can deploy across multiple environments such as VMs, serverless, Kubernetes and Firebase. So for the Cloud Run, we have already discussed. So Cloud Run is the serverless Docker option where you can use to develop and deploy highly scalable containerized application on a fully managed serverless platform. The languages which you can use is Go, Python, Java, Ruby, Node.js and more. So abstract away all your infrastructure management for a simple developer experience using Cloud Run, and you can use the Knative, which is the part of Kubernetes cluster. You can use that in order to manage the Cloud Run. If we talk about the container registry, so container registry is a single place for your team to manage Docker images, perform vulnerability analysis and decide who can access to what fine-grained access control. So container registry is actually the registry where you can just put it the Docker and Kubernetes images and just pull it using the specific commands on gcloud and gsutil. If we talk about the deep learning containers, so deep learning is actually still in the beta phase, or you can quickly prototype with a portable and consistent environment, and you can develop, testing and deploying your AI application with deep learning containers. So Google Kubernetes Engine or GKE. So what's Google Kubernetes Engine? So Google Kubernetes Engine is actually powered by the open source container scheduler Kubernetes. If you use AWS, it's EKS Elastic Kubernetes Service. If you use the Google, you can use the Google Kubernetes Engine. Google Kubernetes Engine is actually manage the whole cluster using the Kubernetes master and worker nodes, and you can deploy your application with high availability scalability. And the Google Kubernetes Engine use the virtual machine in order to manage the cluster. Kubernetes applications are actually enterprise ready containerized solution, and with pre-built deployment template you can feature simplify licensing and consolidated billing. If we talk about the summary, what we have discussed, so Google Container Service offer a comprehensive ecosystem for cloud build to deploy the orchestration using the Kubernetes engine. So it's a mixed match service used with Google Cloud build and Google Kubernetes engine. You can easily deploy the whole infrastructure with CI/CD pipeline. The services prioritize developer simply and efficiency using the managed infrastructure, Google Compute Engine, Kubernetes Engine, Cloud Run, Artifact, and CI/CD. The offering caters to a wide range of container needs, from general purpose application on Cloud Run to specialized solution like deep learning containers for AI development. So the next topic is Google Cloud Armor, Cloud NAT called the network address translation, Google Cloud CDN content delivery network, Google Cloud DNS, Google Cloud Interconnect, which is actually the lease line using dark fibers, Google Cloud Load Balancer, which is actually the global load balancer based on HTTP and HTTPS, network service tier based on the standard and premium tier, virtual private cloud, VPC, service control, VPN, and traffic director. I hope you enjoy the session. Thank you for watching. Hello and welcome again. So now in this section we are going to discuss Google Cloud Platform networking products. So let's get started. In this section we will discuss about Cloud Armor, Cloud NAT called the network address translation, Google Cloud CDN, Google Cloud DNS, Cloud Interconnect, which is actually the lease line, Google Cloud Load Balancer, which is actually the HTTP and HTTPS based global load balancer, network service tier, virtual private cloud or a VPC, and a VPC service control, VPN or a virtual private network, and last but not the least the traffic director, so that you could check from where the traffic is coming and going. So let's start with the Google Cloud Armor. So Google Cloud Armor offers a policy framework and rule language for customizing access to internet facing applications. Is actually the provide the shield to prevent DDoS attacks of your servers and the internet facing applications. Cloud NAT enable instance in a private network to communicate with the internet. If we talk about Google Cloud CDN, is actually the content delivery network which provide the low latency content delivery network for HTTP and HTTPS load balancer, and you can directly configure this with the global load balancer. So Google Cloud DNS. So Google Cloud DNS is actually the managed DNS solution where you can configure the hosted zone and then set up your applications links and the DNS record like A record, MX record, SMTP record, A records, and so on the Google Cloud DNS hosting. Google Cloud Load Balancer is actually the provide scaling, high availability, and traffic management for your internet facing and private applications. So there is two type of load balancer. One is the internet facing load balancer, second is the private load balancer. If we talk about the internet facing load balancer, it means that we are talking about those load balancer which is the global HTTP and HTTPS load balancer and connected in front of the internet. Now let's talk about the network service tier. The network service tier is actually help to set up the network services using a standard tier or the premium tier. This is very simple. If it use the standard tier, it means your traffic will move towards 10 to 12 hops, and if you use the premium tier, the same traffic will come with 3 to 4 hops. That's the difference. Now let's talk about the virtual private cloud. The virtual private cloud is actually just like the lease line, but there is a virtual circuit and you can create this connection from anywhere in the world. Remember, this is not a lease line, this is a virtual circuit, and this is not a dial-up connection. This is a side-to-side VPN where your office firewall connect with the Google Cloud firewalls and create a virtual circuit, and you can upload the data up to 50 to 100 Mbps per second. This VPN connection is secure and encrypted. The service control is the administrative and the security perspective parameters where the different services can communicate with each other with proper authentication and authorization. VPN allow you to connect your existing network to your Google Compute Engine network, and with the help of IPsec connection or two different management VPN gateways, you can easily create a VPN connection. You just need a customer gateway, you just need a virtual gateway, and then it's good to go. So you can easily create a VPN connection, and we will try our level best to show you some demo later in this course. So the traffic director is help to deploy from simple load balancer to advanced feature, and then you using the traffic director you can request routing and percentage based traffic splitting. You can easily split the traffic so that you could consume the specific amount of utilization of a specific load balancer. Let's suppose you have two load balancer, so using traffic director you can split the traffic by 80-20 or 70-30. Now let's talk about the summary. So Google Cloud Platform provide the comprehensive suite of networking product that actually cover the security, connectivity and traffic management without having security and other cloud resources issues. These networking services actually enable to create private network topologies using control access, optimize traffic routing, protect against security threats using Cloud Armor, and denial of services of using DDoS attack. Like I said, is a mix and match services. If you use the network services, you can easily create a mix and match services using Cloud Armor to protect DDoS attacks. Set up interconnect, either direct interconnect or partner interconnect. You can set up the VPN, either single or high availability VPN. You can use the virtual private cloud with multi-region subnets, and the global load balancer with internet facing and internal load balancer, along with the HTTP and HTTPS features. Now let's talk about the next topics. The next topic is Google Cloud IAM, called the Identity and Access Management, IAM concept, and IAM resource hierarchy. I hope you enjoy my session. See you in the next lecture. Thank you. Hello everyone. So just discuss tips about the services. So the first tip is don't just read the service, get hands on dirty. It means whatever service you are learned on the Google Cloud, go and get some hands on the specific service. You can use these services in practical manner by creating a project, and in the specific project you can set up a billing and start working on this project. Google Cloud offer free tiers and credits for learning, and it's approximately $300 for 90 days. I hope you enjoy my session. Thank you for the listening. See you in the next lecture.